So hi there, my name is Catherine Brooks, and I'll be providing the introduction today to our webinar. Thank you for joining. Today we're presenting the webinar, Making Analog Data Accessible, Preserving Data of Scientific and Cultural Importance at Two Institutions. I am part of the Data Curation and Assessment Committee in the Science and Technology section of the Association of College and Research Libraries, which is in turn part of the Association of Research Libraries. So many subsets there. So the outline for our presentation today, first I will continue my introduction, and then we'll have our first speaker, Amanda Bielskas, give her presentation. And then speaker number 2, Sandi Caldrone, will present. And finally, we'll have plenty of time for questions and answers at the end. Everyone should be able to just type into the chat. We will have a member of the Data Curation and Assessment Committee monitoring the chat. And so please feel free to use that. So this committee is comprised of 8 people. You can see all of our names listed here. We're all various science or engineering librarians at different universities around the country. We've got Kristen Adams and Erica Newcomb, who are the co-chairs of this committee from Miami University and the University of Miami, not to be confused with one another. Catherine Brooks, that's myself, from Columbia University. Monica Carroll from University of Illinois Urbana-Champaign. Patricia Hartman from Auburn University. Adam Lindsley from Oregon State University. Christy McDaniel from University of Washington, Tacoma, and finally Alex Weicker from University of Minnesota. So just a little bit of background. We are, as I mentioned, part of ACRL, and we are also part of the Science and Technology section. So I just wanted to share with you a little bit more about us. So the Science and Technology section is a forum through which librarians in scientific and technical subject fields can achieve and maintain awareness of the impact and range of information with which they work. There are section officers, there's a manual, and there's various committees. And it is, as I mentioned, part of ACRL. If you choose to join ACRL, you can also choose to join the Science and Technology section, and that joining the section will be free. Our committee specifically, the Data Curation and Assessment Committee, has the charge to serve as a resource clearinghouse for survey, IRB, and data collection best practices for the section, and advise the membership and other committees on data management. In addition, the committee facilitates submissions from other STS committees producing research and assessment data and long-term storage of STS-created research data in the Open Science Framework. So last year, we presented a webinar on using the Open Science Framework, specifically our kind of page on there. Feel free to reach out to one of us if you're interested in depositing any data there. And again, you can see the list of members here. You'll note that there are a few of us who are cycling off at the end of June 2024. So there will be a few positions open. And please volunteer to join the committee. My next slide actually gives you more information about volunteering with ACRL. So this link will take you to the general ACRL volunteer information page. The deadline for volunteering has already passed, but based on my experience, at least, there's often still some slots to be filled. So if you are interested in volunteering and joining a committee, whether it's on an STS committee or another committee, I think it's worthwhile to still submit a volunteer form. You can scroll down and read more about being a volunteer. I've also included the volunteer form link here. So please note this, I'm not going to actually click on this link. It does require you to log into ALA, which means that you must be an ALA member. And then, so you have to purchase the ALA member, the ACRL membership as well, to then volunteer for ACRL. And then you can join the STS section for free. As a reminder, we will be following ACRL's Code of Conduct. They do have a webpage for their Code of Conduct, which is fairly lengthy. I think I'm just going to highlight a few of the points here on this slide. The main one being, please do not harass anyone. Harassment is unacceptable, and we hope that everyone will engage in respectful dialogue. And in terms of the guidelines, please respect freedom of expression and people's pronouns. You're welcome to put your pronouns in parentheses after your name using the rename function in Zoom. And please listen as much as you share. Finally, I just realized I'm not in slideshow mode. Let me do that. A few minutes too late. Our speakers. Our first speaker is Amanda Bielskas. She is the director of the Science, Engineering, and Social Science Libraries at Columbia University, and she'll be talking about a digital preservation project that she engaged in here at Columbia University, where I also work. And then our second presenter is Sandi Caldrone, who is an assistant professor and research data librarian at the University of Illinois Urbana-Champaign, and she'll also be talking about a digital preservation project that she has been engaged in. And so now I'm going to stop my share and turn it over to Amanda.
Thanks, Catherine. Let me just share my screen so I can start my presentation. Launch my presentation. Okay, can everybody see my screen? Okay, great. Thank you to Catherine and the rest of the committee for inviting me to give this talk today. Hopefully I'll stay on time and we'll have plenty of time for questions. I'm going to talk today about a project that we did here at Columbia that made a collection of gray literature of print technical reports digitally available in our institutional repository, as well as several other systems and platforms. This presentation that I'm giving today was heavily adapted from a talk that was given at the Northeast Institutional Repository Day in December of 2021. And I would really like to thank my colleagues that worked with me on that presentation. And those colleagues included Esther Jackson, Emily Holmes, and Melanie Wacker. This, like I said, is heavily adapted from that presentation that we gave together previously. So a little bit about the reports that we digitized. The Lamont Doherty Earth Observatory technical reports are a collection of scientific reports that dated from 1949 to 2003. A cross-departmental team at Columbia set out to digitize 298 of these technical reports that comprised over 32,000 pages, which also included 151 foldouts of various sizes, which complicated the digitization project a little bit, but not too much. And most of these materials, or this collection, was essentially a hidden collection, as most of the material was not already in our catalog. The material was not in our collection, and the material was not available electronically. These technical reports had been published in-house at Lamont Doherty Earth Observatory, which is part of Columbia. And they capture and document the scientific data that was collected on many research cruises and expeditions over that time period. These reports were often required to partially satisfy funding agencies' reporting requirements, and they documented expedition objectives. They presented some of the data that was collected and documented the methods used in the data collection. The reports often included maps, charts, tabular and other displayed data, including the foldouts that I previously mentioned, of varying dimensions. Some of the reports were done in conjunction with other governmental agencies, including like the Navy or the Army. And this collection had not been cataloged, digitized systematically, and was basically at risk for loss if we did not preserve and help make it more discoverable. So our project aims and goals included making the collection more discoverable, both through our catalog and also through the WorldCat. We hoped to ensure the long-term preservation of the documents, both physically and digitally, and we also wanted to determine the best place to hold the items or host the digital items. So Academic Commons is the digital repository at Columbia University and its affiliated institutions. Currently, we have over 40,000 works that are accessible through the institutional repository. And we're always looking to find new ways to add content from unique collections to our institutional repository. So for this particular collection, the metadata for it was largely available through WorldCat, and for this reason, we developed a workflow that divides and enabled the team to reuse the existing MARC records at the same time, increasing access and visibility of these resources by making them digitally available through WorldCat, HathiTrust, the library's catalog, which is called Clio, Internet Archive, and Academic Commons, which is our institutional repository. The project had 21 team members and started in July 2019 and completed in September 2020. This slide is showing the workflow that we designed for this project, and it involved the digitization of the original print reports, the cataloging of the physical and digital copies, and dynamically crosswalking the MARC data from our catalog to a MODS-based format for Academic Commons, which is our institutional repository. The reports were assigned DOIs and were made available for download. The materials were sent in bulk to Internet Archive in Princeton, New Jersey, and Internet Archive scanned and uploaded the materials along with the, oops, sorry, I think I want to stay on that screen for a second. So along with the MARC metadata, they extracted it via the Z3950. 100% of the quality control for the metadata and page imaging was done in-house in our preservation department at Columbia, and any corrections that needed to be made were then done by the Internet Archive. After those records were cleaned up, they were sent to our library systems, and they batch cataloged and also added resolver URLs to those new records. We then gathered the full list of those records to the staff at the institutional repository, who then downloaded the PDFs directly from Internet Archive and uploaded them to our institutional repository. And then after that, they were then made discoverable. So then all of these materials were made discoverable via the Internet Archive, Google, our library catalog, and our Academic Commons, and through HathiTrust, where they were, that's the long-term preservation solution that we came up with for them. So this slide is an example of the MARC catalog record within our catalog, and the cataloging department basically set to work to download the existing MARC records that existed in WorldCat, and then they also had to create MARC records for reports that had not been cataloged yet by any other institution. This slide basically shows a brief view of how the electronic and print records appear in our catalog, as at Columbia here, we follow a separate records policy for electronic and print formats. So we keep separate items for both print and electronic items as separate entities. And then this is just like a display of the different ways an item is displayed in the different systems. So you have the physical object, the view in HathiTrust, the view in Academic Commons, and the view in Internet Archive. And then this is a larger version of a record in Academic Commons, which is our institutional repository. We also, as part of the work to get them into Academic Commons, our metadata folks had to basically figure out how to treat this as a collection so that it could be identified as a collection in Academic Commons. So that was kind of an interesting twist on the project to be able to make them discoverable in this system as a collection. Because Lamont Doherty Earth Observatory and these report series had changed names several times over time, keeping them as a catalog, as a collection was a little bit of a challenge. So I thought this group might be interested to see if the collection is being used, and the answer is yes. We got this download data from the folks at our institutional repository as of the end of March. The total number of lifetime views for the collection in our repository was over 19,000. And the lifetime number of downloads for all of the reports in the repository was over 31,000. And this chart shows use over time, both by fiscal and by calendar year, since the collection was launched in 2020. This does not reflect data or use from Internet Archive or HathiTrust, which are different systems, and I didn't have the time to gather them for this presentation. But the good news is these reports are getting used. And then this is a different way to look at use. This is the number. This is the highest use titles. So these are individual titles in the collection, the number of views and download sorted by download. So these are the most downloaded reports in the collection according to use in the repository. So it's really great to see. And we started this project several years ago, and I really hadn't taken the time to go back and look at any of the use. So it's really good to see that the collection is getting used. I thought it would be, but that was just a guess when we digitized this collection. So it's really great to see that it is getting strong use. So what did we accomplish? The project was successfully completed and the collection is actively being used, which is great. This product process has also been used successfully on other projects and has been used as a model for getting other materials into Academic Commons, our institutional repository. There's a couple other accomplishments more on the technical side that are on this slide as well. So hopefully folks here can learn from this and, apply some of this process to potentially similar projects at their own institutions. I'd like to thank all my colleagues that had a hand in working on this project and shepherding it through its completion. It was the work of many departments across the libraries and many stakeholders, and represents what we can accomplish when we are working towards a common goal. So this is all of the people that had some hand in the project, both from sponsoring, help supporting it monetarily through collections funds, and then also doing the work to digitize, quality control, and getting it into all of these systems. So that concludes my presentation, and I think we'll take questions at the end, if that's
Yes, we'll save all the questions for the end. So just a quick announcement. The Zoom link that was sent out to join this webinar mistakenly names everyone entering the Zoom as Kristen Adams. I'm hoping that some of the attendees are able to change their names. I usually hover over the 3 dots in the upper right corner of my picture or of just my tile that has my name on it, and then you can go down and rename. So if everyone could try doing that, that would be great, and let us know in the chat if it's working. Great. Well, thank you very much, Amanda. That was really interesting. What an enormous project, and like such a large team. That's very cool. And next we'll have Sandi Caldrone.
Hi, thank you. Yeah, let me just share my screen here. Okay. So I'm Sandi Caldrone. I'm a research data librarian at the University of Illinois Urbana-Champaign. And I'm going to be giving you a little tour of a historical data set that I've done a lot of work with called the Morrow Plots. So the Morrow Plots are a long-term agricultural experiment that has been going on at the University of Illinois since 1876 is when they were first planted. They're actually the second oldest continuous agricultural experiment in the world. Next to Rothamsted, England has another farming experiment that's been going on since, I believe, the 1850s. So they have great scientific value for that reason. A lot of trends in agriculture show up over long time scales. So short-term experiments often aren't enough time to test things such as the impact of continuous cropping on soil quality, which is one of the things tested in this experiment here. So if you're not from Illinois, then maybe you don't see cornfields every time you drive to a new town, but that is the experience leaving the University of Illinois campus. And that's because corn is the most important crop in the state and has been for many years, really since agriculture industrialized. And this experiment was designed to test, and it sounds kind of silly now, but it was designed to test whether or not fertilizers would help or harm the growing process, because this was a matter of debate. There were many people who thought that the prairie soils of the Midwest were so rich that adding anything to them in terms of nutrients would actually do harm. And so what this experiment does is we have a farm field that is split into subplots. Some of those plots get fertilizers, some of them don't. All of them grow corn. Some of them grow corn all the time. Every year they've been growing corn since the 1870s. Some of them rotate corn with other crops. And so those are the two main variables that this experiment tests. And when I say these are in the middle of campus, I really mean these are in the middle of campus. The campus has grown up around them over time. And this is one of the reasons why we could justify doing the kind of like investment of time and labor in making these data digitally available. So not only do they have kind of historical agricultural value, because they're so centrally located, everyone sees them. They have kind of also a cultural value to the university as well. They're included on every university tour. They get mentioned in every summary of the history of the university. And so that was really important to the team I worked with on working with this data, because it's just not possible to put this kind of time and attention into every analog data set. But because this was so central to the university, it was very well justified for us to invest the time here. And so, as with Amanda's project, this was very, very much a team effort. I'm part of a data curation working group that has been working on this project since 2018, which was before I even came to the university library. And so this is made up of folks from the College of Agriculture, from our university archives, from our agriculture library, and also from our research data service team that I'm a part of. And so this has been a multi-year project that began with really just trying to locate data sources, which took a lot of time in interviewing scientists who are currently working on the plots, people who have worked on them in the past, published on them in the past, Several publications have come out about the Morrow plots over time. There have been lots of bulletins and reports and circulars distributing, results of usually a couple of years, sometimes a longer summary. But until the data curation group formed, there had never been a published digital data set of all of this accumulated data from the plots. And so a lot of our work started with just actually trying to locate those files. My role came in a little bit later. I joined the university in 2021, and my role was really in like cleaning and combining and making the data machine readable once we had been able to find those data sources to start with. And so I'll give you an overview of what those data sources are. We had three main data sources, and they're a mix of analog and electronic data. So our oldest data source goes back to 1888, not all the way back to the beginning of the experiment. As far as we can tell, there have never been any records from before 1888, but I'm still holding out hope that something might turn up someday. So we have a handwritten notebook that covers 1888 to 1913. We also have printed reports that were created for publication. And as well, we also have an Excel spreadsheet that was an internal record used for many years by the farm managers managing the plots. And so our task was really to marry all of these together into one coherent data set. And so I'll just give you a preview of what those look like. So this is a page from the notebook. And actually, this is digitized. And I'm going to drop some links into the chat. One of them is for this notebook. So this notebook has been digitized and is available online. It is entirely handwritten by multiple authors. It also appears to be a compilation of previous field notebooks. Just by kind of the way it was written, it seems as though they had all of this information before they probably decided to make a cleaner copy of it in this notebook. Although, as you can kind of tell from this screenshot here, there are some like additions and changes and corrections throughout, which is just, one of those fun challenges of working with handwritten data. So we have that kind of annotation in here. We have some data tables, and then also a lot of data that's hidden in narrative paragraphs describing the farming practices, what fertilizers were applied and in what amounts. So a lot of this required a really close reading to pull out what we would now want to include in a data table. We also have printed reports, and these are in one of the links that I dropped into the chat. These are very kind of clean, unlike the handwritten notebook, but also unlike the handwritten notebook, very, very sparse. So here we have yield data for the crops on the different subplots, and they're kind of divided depending on the kind of soil treatment they receive. So while we have kind of rich, messy narrative data in the notebook, we have extremely kind of like rigid, but very, very sparse detail in these printed reports. The data curation working group was able to get I guess, digitized record of this from the College of Agriculture, where someone had recreated these reports as they kind of appear here in an Excel file. So we had that to start with. We didn't have to key in the data ourselves, but it was in a very not machine readable format. So it required quite a bit of work to get things moved around and in what we wanted to be our kind of final state for the data. Oh, I'm sorry. I think I might not have sent the links out, but it looks like they've been shared. Okay, thank you so much. So this was really my role in the project, the combining and cleaning of these different data sources. And I did that in a combination of Excel just to get started. So kind of minimal cleaning and conversion to CSV, because we really wanted as much of the process as possible to be recorded and transparent, and Excel really doesn't provide for that. So once things were just kind of in a CSV format and it had clear headers, really, I was importing those into our studio, where I was then cleaning, compiling, and transforming those into the tidy data format, so it would be highly machine readable. And so I did that in various stages, and do have that code available in GitHub if anyone is interested in seeing more detail about that process. Throughout, it was really important to make sure, you know, in terms of quality assurance, that none of this data was getting jumbled. So the kinds of data we have here are things like what crops were planted, what the specific breed of crop, the planting date, if we have it, the exact location in which subplot, what fertilization strategy applies to that subplot, and the yield for that crop. There are also a few other variables as well that I won't get into detail about. But there's a lot, and it could easily, you know, one year looks very much like another. So it's really important that we made sure that we were maintaining the integrity of this data set while it was being manipulated and transformed. And one of the ways we did that was through exploratory visualization throughout the process, to ensure that we had still a complete data set. We were seeing everything we expected to see, and we could match those visualizations against other kind of like published visualizations of the results of the experiment, so that we could make sure that we retained the quality of our data. And then, of course, we also did specific like spot checks, looking at a row of data and in our new clean data set and matching that against the original source to make sure that everything was maintained. And so the final data set looks like this. This is in the tidy data format. So one variable per column, one observation per row, one value per cell. The format's very machine readable, so it should be easy to load into any data analysis program. And it has lots of detail. This is in part because we were lucky enough to be working with domain scientists throughout the process, who were able to tell us what was and what wasn't important to maintain in the data set. And because this experiment has been going on for so long, it's changed over time. We have, you know, some records for some years and not for others, like, for example, like specific planting dates. We have the exact dates for some years and not all. From a data science perspective, we often think of, you know, we might think of this data as being too sparse to be useful if we only have it for maybe 10% of the experiment. But the agricultural scientists were able to tell us that no, even this sparse data is still very valuable and needs to be included. So that's part of the reasons why it's so very detailed. And so we were able to publish this data set in the Illinois Data Bank. That's our institutional data repository. And the experiment is still ongoing. So we plan to version this and put out additional versions with new additions of data. So the data set that's currently published goes through the harvest data from 2021. We have new data from 2022 and 23 to add into that. We also are working on other projects related to this data. One of the kind of wonderful side effects of this project is that the Research Data Services realize it's also a great kind of educational tool for us to use as we're talking about data publication and about data management and data cleaning. We can point people to this data set as a strong example of tidy data. We put a lot of time and effort into the descriptive materials, so the README file and the code book are quite detailed. So we point people to those as examples of data documentation. And our experiences in working really hands-on with this data, while it's not something that we normally do for researchers, when we're consulting with researchers, we can draw on these experiences and use those as an example. So we found that, even though we kind of finished the main phase of this project, it still is serving us really well. So we're continuing to work with it. And so some of the things we kind of have on the horizon are we're working on a data descriptor paper to provide a lot more detail about the data itself than is in the code book. We also have an R data package in the works. So this would be, if you're an R user, you might be familiar with packages you can download from the CRAN repository. So basically, this would just allow folks who are using R to use some easy commands to install and import the Morrow Plots data so they can use it in their own R instances. And we found that this data set, because it is, since the experiment has been going on so long, it's kind of a simple, relatively simple experiment about what you do to the soil and how that impacts the crops that you harvest later on. And we found that most folks from any discipline can understand this kind of basic model. I have zero background in agriculture, so I can attest to that. So we think that it has value as an educational data set as well, and hopefully in our data package will help more folks use this in an educational setting. We are also continuing to try to find additional detail from historical sources to add to this data set. So the published data set has almost entirely complete yield figures from every season. We have fewer figures for the specific amounts of fertilizers applied to the soil. However, those are mentioned in a lot of historical reports. So one of the things I've been doing lately is trying to comb through those and pull out some additional detail that we can add to a future version of the data set. We're also working with the laboratory that oversees the experiment. They have a large specimen collection of soil samples. And so at some point in the future, we hope to be able to kind of link this Morrow Plots data to the samples of Morrow Plots soil that are in their specimen collection. So a historic experiment, but still lots going on in the present day. So these are kind of our next steps. I didn't go into a lot of detail about the data because we want to make sure we have plenty of time for questions, but if anybody wants to talk more, I'm happy to bore you to death with Morrow Plots data because I love talking about it. So let me go ahead and stop sharing my screen. Okay, great.